This video includes key information for topics 9 and 10 talking about transformations. So what we have learned is that there are 4 types of transformations. The first is translations, and the common word for that is slides. And when we talk about slides, we have a rule, and the rule tells us how we move. So translations have rules that always start with XY. Then we have an arrow that we read as goes to. And then we have X, and then we'll have a plus or minus sign. So I'll put a plus here, and then I'll put a minus here. And then we're going to fill in numbers there. The same thing with the Y. We'll have a plus or a minus there, and then a number. So if you have a plus sign with the X's, remember the X values on a coordinate plane go right and left. This is the X value, X-axis, and this is the Y-axis. So if we have X plus 5, that means we take our X and we add 5 to it. So that would mean that if my X was here at 2, I would have to slide it to the right 5 spaces, and my new point would be here. So plus 5 means right 5 with the X. If I have X minus 2, we take our X value and we subtract 2 from it, which means we slide it to the left. So that means left 2. Now let's talk about the Y values. So if we have a Y plus 4, that means we take our Y value and we move it up 4 units. So plus 4 means up 4. And then we have a minus sign. So if I have Y minus 6, I take my Y value and I move it down 6. And it would be right there. So down 6 if it's minus with the Y. Okay, so we have our translations, which are slides, and we move all the points. Several students are saying you translate over an axis. That is not a common way to write things in math. We don't translate over axes, we translate distances, and the distances are shown with the rule. All right, let's move on to reflections. So our next one is reflections, and another common word for that is a flip. Now, we flip things over lines in the coordinate plane. So if I have my axes, and I start with any kind of shape here, so this is A, B, and C, and we can flip it over any number of lines, but let's start with an example where we flip it over the Y-axis. So if we flip this over the Y-axis, I'm going to highlight the Y-axis in red, and I'm going to see how far apart each point is from that Y-axis. So point A right here is 2 spaces away from the Y-axis, and it's to the left, so I need to reflect it 2 spaces to the right. So my new coordinate is going to be here. And remember, when we have a new coordinate, we name it A prime. So the primes tell you that you have the image now. If I take a look at B, B is 3 units away from the axis that I'm flipping it over. So I need to go 3 units the other way. So I will end up right here for B prime. And then let's do C. C is also 3 units away. So I want to go 3 units away in the other direction. And that's C prime. So now I connect the dots. And you will have a straight edge to do those connections. I'm drawing it freehand. But you should end up with congruent figures that reflect over the y-axis. Now let's take that same figure, and what I'm going to do is I'm going to erase all the red stuff, and now we're going to do a reflection over the x-axis. So I'm going to highlight the x-axis in green, and I'm going to see how far away each point is from the axis. So A is 5 units away from the axis, so I need to go 5 units in the other direction. So my A prime is going to be 5 units below the x-axis. For my B prime, B is 2 units above, so I need to go 2 units below. So what's going to happen here is that B prime is going to be exactly where C is. And when I reflect C, C was 2 units below, so I need to go 2 units above, so C prime is going to be where B is. So that's C prime. So then I connect the points. And that triangle is the image of triangle ABC. The next thing I'm going to do, I'm going to erase all the green, and now I'm going to choose a different line to reflect things over. So let's reflect it over the line y equals 1. So first of all, y equals 1 right here, 1 on the y-axis, and so the line y equals 1 is going to be that horizontal line where all of those y values are 1. So I'm going to follow that same rule where you count how far away each point is from the axis. So A is 4 above, so I'm going to go 4 below. So A prime is going to be 4 units below the yellow line, not below the axis, but below the line of reflection. C is 3 units below, so I'm going to go 3 units above the yellow line for C prime. And B is 1 unit above the line, so I need to go 1 unit below the line for B prime. And once I have those coordinates, I'm going to connect the dots. You would use a straight edge, and you have your image. Okay, so that's reflections. Let's move on to rotations. So with rotations, we are talking about turning. And we really just need, for this class, to know about the 90-degree angle, the 180-degree angle, the 270-degree angle, and the 360-degree angle, which is a whole turn. Alright, so when we have to rotate things, you have to remember that clockwise means we have a negative angle of rotation. But what I want you to realize is if I give you a question where I ask, what is the angle of rotation? I want you to give me the degrees and the direction, either clockwise or counterclockwise. Counterclockwise would be positive angles. Okay, so we're going to try to rotate a figure. So let's put a figure on here. And we're going to try to rotate it so let's do triangle ABC. And I'm going to rotate this 90 degrees clockwise. So what I'm going to do to help you out is I'm going to highlight the axis here in yellow, and then this axis I'm going to highlight in red. So when you have to turn 90 degrees clockwise, and we're going to have about the origin, which is what we're always turning it around in Math 8, what we're going to do is we are going to switch or turn the axes 90 degrees clockwise. So if I turn this 90 degrees clockwise, that means the red becomes the yellow and the yellow becomes the red. So it will end up where the yellow is here and the red is here. So if we look at where A is 2 to the right on the yellow axis. So if I turn that, I'm going to go 2 down on the yellow axis. So it's 2 to the right, and then I would go up 3. So if I turn it, I'm going 2 down and right 3. So that is where A prime is. If I look at where B is, I go 1 to the right and 1 up. So that means I'm going to go 1 down and 1 right. So B prime is at the point 1, negative 1. And C, we go right 4 and down 1, So on the yellow axis, I'm going to go down 4 and left 1. So I'm ran a little out of room. Let me make this go up a little bit. So this is C prime. So I connect A prime, B prime, and C prime. And that's the rotation of 90 degrees. Now I will admit that this is hard to understand the way I did this. It would be much easier if I could show you I can turn my paper. I'm just not capable of doing that with this program. So if you need some more help on rotations, please ask me. So another important note that you should write down is that translations, reflections, and rotations all keep the same size and shape. Of the figures. And because of that, we say that they are congruent figures. So the pre-image and image are congruent, same size and shape. So we use those 3 transformations to prove congruence. Okay, I would like to go back for a moment to the reflections and talk about orientation. So orientation can be either clockwise or counterclockwise. Now, we can rotate things clockwise or counterclockwise. That's different than the orientation being clockwise and counterclockwise. So if we talk about figure triangle ABC that I have in black, if I start at A, I go to B, and then I go to C, I am moving in a clockwise direction because that's how the clock moves. So I would say that the orientation of triangle ABC is clockwise. If I look at triangle A prime, B prime, C prime, and I go from A prime to B prime, then to C prime, and back, I am going in a counterclockwise direction. So A prime, B prime, C prime is counterclockwise. When this happens, when the image and the pre-image have opposite orientations, there must be a reflection involved. So that's what you want to look for when you have to figure out how to map one figure onto another. Alright, what we want to do now is talk about dilations. So dilations involve a size change. And a dilation can be an enlargement and that happens if the scale factor is greater than 1. And we also have reductions if the scale factor is between 0 and 1. So the scale factor is between 0 and 1, the figure will get smaller. And to find the scale factor, we take the length of a side of the image divided by the length of the side of the pre-image. And if you don't know the length, then you can find any horizontal or vertical distance, and that will work. Okay, so if I have two figures where one is bigger than the other, but they have the same shape, they're called similar figures. So I'm going to have a triangle that looks like that, and a similar triangle that looks like this one. So these two are similar. So what I have to do is I have to find the transformations that map, let's say this is A, B, C onto X, Y, Z. Alright, so let's go ahead and put some axes here. Alright, so I have to come up with a series of transformations that maps ABC onto XYZ. So the first thing I'm going to do is dilate ABC so it's the same size as XYZ. So dilate first, and to dilate I need to know the scale factor. So if I look at the length from A to B, that's 4. And from X to Y is 8. So it's the image over the pre-image, so 8 over 4 equals 2. So it's a dilation with scale factor 2. And I'm going to make the center 0, 0, which is all I've taught you to do. Some of you have dilated it differently, and I can talk to you individually about that. So if I use a scale factor of 2 with the center at 0, 0, I take all my coordinates. So my coordinates here are -4, 1, and I multiply them by 2. So I get -8, 2. So here is going to be A prime. And I'm going to take my B coordinate, which is -4, 5, multiply by 2, I get negative 8, 10. So I'm way up here. That's B prime. Oops, sorry about that. And I'm going to take my C and multiply the coordinates by 2. So the coordinates are negative 2, 1. So I'll get negative 4, 2. So right here is C prime. So now I'm dealing with this triangle right here. And I have to get it onto the blue one. The next thing I do after I look at dilations is I look at the scale factors. I look at the orientation. So if I go from A prime to B prime to C prime, I am moving clockwise. If I go from X to Y to Z, I'm going counterclockwise. So since clockwise is this one and counterclockwise is this one, I know that the orientation switches, so therefore there's going to be a reflection. So now I'm going to reflect. And then I have lots of choices on what I want to reflect it over. I don't want to reflect it over the x-axis because that would turn the triangle, that would flip the triangle upside down, and that's not what I want. I want the triangle to flip sideways. So I'm going to go ahead, and you have a lot of choices here, but I'm going to go ahead and flip it over the y-axis. So I flip it over the y-axis, so C prime is 4 units away here, so I want to go 4 units away here. So C prime is going to be right there. I'm going to call it C double prime since it's the second time I've moved C. A prime is going to flip over the y-axis. So A prime was 8 away from the y-axis, so I need to go 8 the other way. So A double prime is here, and then B double prime is way up here, and it was 8 units away up here, so I need to go 8 the other direction, which is right here. So that's B double prime. And it's making a mess through all my words, but we have this shape here. Now, what do I need to do to the red triangle to get it to be on top of the blue? So I need to move it down 5 units and left 2 units. So I'm talking about a translation. So left 2 and down 5 will put me on top of the blue one. And that is how I move one onto the other. I'm going to make another much shorter video to describe how to do problems like number 12 on the practice tests.